are going upwards because the disc is rotating in a clockwise direction. Okay, so we are going to neglect the size of the pulley of C. So we are going to mention that radius. Yes, sir. Oh yeah, sorry. I think I'm blind today. You're right. Positive. Anti-clockwise. Why am I saying that it's clockwise? Thank you. 2 pints. Or orange juice, okay? So we know over here, what we can see over here, we know that the radius at point C is what? Okay, is neglected. Okay. So now we are going to draw, okay, we are going to draw the critical part is point A, point B, or I'm going to call this point A, point C, and I'm going to call this point over here, I'm going to label this at point D. Okay. So we're going to sketch this out. Okay, so we are going to draw a triangle. Okay. So this is our point D. This is our point A. And this is our point C. Okay. And what we are given over here, this is our theta. Okay. Over here is our theta. So we have to determine, what we have to determine is our what? Our V, AC, and our AC. Okay. Now point A or point A or A is not what? It's not fixed. If you look at what is going on, point A is basically a what? A pin, right? When theta changes, you will have a what? You have a, if I were to call this our X and Y coordinates, right? You will have a AX and a what? And a AY. It's changing with time. Okay. So we have to determine VAC and AAC. Why that is that? Why we have to determine these points? Because we know, okay, VAC, right, is equal to our VB, and our AAC is equal to our AB. Okay, that's what we know. Okay. So we are going to use, I think it's called cosine rule, right? We have this expression, okay? So what I'm going to write down here is, if this is our A, the distance from here to here, we label this as A, and the distance from here to here, we label this as B, and the distance from here to here, we label this as S, okay? Or we call it as a variable S. So from here, I can't remember what is this called mathematics. Is it cosine rule? Where you have S squared is equal to A squared plus by B squared minus by 2AB cos theta. What rule is this called, anyone? Hey? Cosine rule, right? 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 So you have this expression over here. Okay. So now the important thing is now we know the distance between what? AC, right? This S is important over here because from here we can differentiate, we can get what? Why this is important, right? So S is the distance between what? Between point A and point what? C. So from here, we can do ds over dt. We will have our what? VAC. And then we can have our ds squared or d squared s over dt squared. This is our acceleration of AC. Okay. So this is the link that we just discovered to determine our velocity and our acceleration. Okay, so from here, I'm going to call this equation our. Okay, so from equation number 1, this will be S, and then will be square root of A squared plus by B squared minus 2AB cos theta. Okay. So all we are left to do is put in numbers now. Okay, so with the figure that we are given, we know that A is equal to 3, right? A is equal to 3, B is equal to 5. Okay, so we start putting in numbers. So S is equal to square root 3 squared, 5 squared, 3 multiplied by 5. And then we just do a cos theta. Okay. So over here, 3 squared plus 5 squared. So 25 plus 9 is equal to 34. Minus by 2 times 3 times 5, 30 cos theta. And all we have to do now, this is the power of half. Okay. So we're going to differentiate ds over dt now. So this is our equation number 2. Okay. So we differentiate. So this will be equal to half 34 minus 30 cos theta minus half. Okay. Then we have 30 sine theta. And then we have d theta over dt. So this will be equal to 15 sine theta, and d theta over dt is equal to omega. And this will be equal to 34 minus 30 cos theta power of half. Okay, so just to rearrange this, so this is 15 omega sine theta over by 34 minus by 30 cos theta power half. Okay. So over here, this is our equation number 3. So because of the form of equation number 3, it made our differentiation later on slightly not difficult, but lengthier. Okay, so it goes longer. So from here, I'm going to divide the page into 2. Right. So over here now, I'll make sure you can see both of them. So we are going to do d squared s over dt squared. So this is equal to our acceleration of AC. But before I go on, we have already determined our velocity of what? AC already. So that is our velocity of AC. So from here, right, then you have 15 omega sine theta divided by 34 minus 30 cos theta power of half. So we are going to use this expression, right, where we have d squared x over dt squared, and this will be equal to v du over dt minus by u dv over dt, and over here we divide by v squared. I think this is called, any idea? Am I right? Okay, so you guys are good at it. I'm not going to write all the expression out, okay? I will just tell you what I did. So I let u is equal to 15 omega sine theta. Now down here, we also need to sorry, I skipped steps. Over here, down here, we know that omega and theta is a function of what? Function of time, okay? So you have du over dt. So this expression will be equal to 15 sine theta d omega over dt. And then plus by 15 omega cos theta d theta over dt. Okay. Then the next one, we are going to let v is equal to 34 minus 30 cos theta power of half. Okay. So when we do dv over dt, this will be equal to half 34 minus 30 cos theta, and this will be equal to minus half. Differentiate theta in terms of time is equal to 0. Cos, you differentiate, you become positive, negative, negative, become positive, and you get d theta over dt. So when you assemble everything together, you have 15 sine theta divided by 34 minus 30 cos theta power of half. Okay. And then you have the expression over here, d theta over dt. Okay. I'm just going to give you the final answer. Okay, I'll let you work up the steps. Okay. So the final answer is acceleration for AC will be equal to, wow, 15 alpha sine theta plus by 15 omega squared cos theta, and then the whole thing we divide by 34 minus 30 cos theta power of half minus by 225 omega squared sine squared theta. Okay. And then finally you have 34 minus 30 cos theta, and this is 3 over 2. Okay. So that is your final expression. Okay. So again, the rules did not change with all the examples that we have done. Okay, the procedure is you have to get a relationship between position and a function of theta, and then you just need to carry out your differentiation twice. First time to get your velocity, the second time to get your acceleration, and all you need to know is your product rule or your quotient rule, then that's it. Okay. How much do we use absolute motion? Okay, not so much, very limited application on this, but more important is our relative motion analysis. Okay, so we are going to start on a new section.